Hi class, this is your instructor, Skylar Huff. Welcome back, and we have now made it to the 5th chapter of the textbook, and this chapter is titled Tissues. So just be sure that you are using those learning objectives, as those objectives are what will be, of course, used to make your tests. And if you're wondering what I'm referring to, I'm referring specifically to those learning outcomes. So for each of the headings that are in the textbook, such as what you all can see on page 150, it begins with cells are organized into tissues. And then there are 3 learning outcomes that follow. For instance, it says, describe how cells are organized into tissues. Number 2 says, identify the intercellular junctions in tissues. And the third one there states, list the 4 major tissue types in the body, then indicate locations and functions of each type. So having done that, just ensure that by the time that you have gone through the entire chapter, section by section, that you've mastered those listed learning outcomes. Because I would say it this way, if you can, of course, go through those learning outcomes and state, describe, identify, list, provide those locations and functions, you are appropriately prepared to do well on the test. So let's jump right into the chapter. So here we are in human anatomy and physiology, and we finally get to tissues. So in us, who are tissues, just keep in mind that a tissue is nothing more than something that's made up of similar cells that carry out specific functions. So having said it that way, yes, a tissue is a group of similar cells with a common function. And by studying human tissues, it's referred to as being histology. This reminds me of the histology course I took back as an undergraduate, and that was one of the more challenging courses I've had in my life. And I was glad for that spring semester to be over, and as soon as it ended, of course, graduation occurred. But to get back to where we are, in this chapter you all will learn about those 4 basic types of animal tissues. They are as follows: epithelial tissue, connective tissue, muscle tissue, and nerve tissue, or even known as nervous tissue, depending upon who's teaching you. This table shown here is table 5.2. It's shown there, and it can also be found in your textbook on page 152. This puts a lot of things in one spot. And I don't know if I've said it many times or even any times at all, but I like tables, I like charts, because it puts a lot of information in one spot, and it's great for learning. So please use this as you all go through the chapter. I'll now continue. So we'll begin, of course, with intercellular junctions. So as we are here, yes, we have those cells, and those cells must come together. Well, those cells come together at some junction. So there are differing junctions I have for you, the first of which is that tight junction. So the tight junction, it just states that these are tight, and they specifically join cells that form those sheet-like layers, such as those inside our digestive tract, or even those lining our blood vessels found in the brain. So those tight junctions are there to ensure that things cannot get out. I'll move on to the next. So the next of which would be, of course, the desmosome. So with desmosomes, they're like spot wells on our skin cells. So they are that reinforcement structural unit. And with this, we find those on our outer skin cells. And then lastly, we get to gap junctions. So with gap junctions, those are just as it sounds. They're just those tubular channels that are interconnecting those individual parts, such as you find, of course, between those cardiac muscle cells and even in the smooth muscle of the digestive tract. So this allows ions and nutrients to pass, such as the sugars, amino acids, and even nucleotides. So having done those, we'll now get into where we're going. And where we're going, of course, is from science to technology. So this is with the blood-brain barrier. We'll do a lot more with this in the 12th chapter, in the 11th chapter. But it's previewed here, class, on page 151. So with nanotechnology, it has helped drug developers get around the problem of drug delivery, and it's all because of those junctions I just mentioned, those tight junctions. So with this, it just mentions that the blood-brain barrier is, of course, what shields brain tissues from toxins and biochemical fluctuations that could be, of course, overwhelming. So with this, it allows selective drug delivery, and certain antihistamines, for example, they cannot, I repeat, they do not cause drowsiness, and it's all because they cannot get through that blood-brain barrier. But of course, the blood cannot take up many therapeutic drugs because they must penetrate the blood-brain barrier for effectiveness. So with this being stated, they're trying now to deliver those drugs and tag other compounds to substances that are able to cross. So with nanotechnology, dealing with, of course, micrometers, meaning zero point 0.1 micrometers, and they're just trying to get those things in. So the nanoparticles that can cross the blood-brain barrier are made up of combinations of oils and polymers. And with this, one application would be, of course, with anesthetics and even chemotherapeutics. So that's just an instance in it. And in another application is with insulin being delivered by way of an inhaled nanoparticle that's 10 to 50 nanometers in diameter. So with this, it was developed to provide insulin to people with diabetes instead of injecting it. So by nanoparticle delivery of the insulin, it may be helpful to maintain, and of course, the memory in people who have mild cognitive impairments or even with Alzheimer's disease. And that we'll also get to in chapter 11. So as I can pick back up where I've left off, we'll now get into the first of which being epithelial tissue. And before I jump there, I just thought I should go back just a moment to the career corner found on the bottom right-hand side of page 151. So it states, it's 5 a.m. in the morning, and the tissue recovery technician reaches for her cell phone. So a young man has died in a car crash of head trauma, but his skin is intact and healthy. The technician drives to the funeral home just a few miles out of the city, relieved that she doesn't have to travel as far as she did the last time she was on call. She's available to recover tissue for 5 24-hour periods each month. At the funeral home, the technician puts on a mask, gloves, and then disinfects and with antiseptics the area of the skin of the corpse that she will use for excise. And then she will remove the tissue using sterile surgical instruments, and she will store and package the tissue, then ship it to a tissue bank, and of course, carefully recording the details of the procedure. The technician is comfortable working with the corpse, and she knows that even though the accident had a tragic end, several burn victims may receive grafts from the donor, and after the tissue bank determines which patients will be most compatible with the grafts. So recovering tissue, which is stored, is less stressful than recovering organs, which must be used quickly. In addition to skin, tissue banks store bone, corneas, tendons, ligaments, cartilage, blood vessels, and heart valves. So a tissue recovery technician therefore must have excellent fine motor skills and knowledge of anatomy. And the job requires standing for long periods of time and possibly lifting bodies. So this is something that should be, I would say, looked into by any of you all who are interested in, of course, tissue recovery or anything in this matter. This takes us about to where we're going to go, not so much as in this chapter, but in the chapter to come, being chapter 6, when we get to, of course, the integumentary system. And this leads me into where I know we're going to go. And since I already know where we're going to go, I'll go ahead and begin to foreshadow now. So on your upcoming test, being your third test of the semester, what you all should do is take yourselves to, of course, chapter 6. And upon arriving in chapter 6, what you all should do is look at figure 6.2. Figure 6.2. So what you all should do using figure 6.2 is prepare yourselves to be able to label 6.2a in its entirety, and then provide the function of each of those parts found in figure 6.2a. So this, of course, will be not necessarily an essay, but of course it will be much like an essay will be. In other words, instead of giving, of course, I guess I'll say 2 traditional type essays, you all will label and provide the function of each of these items you see listed here. And I'll also post to Canvas a piece of paper, meaning a document, of this very same thing for you all to label and provide, of course, the functions, so that if you all would like to practice at home while you're at work on break or just anywhere you are, you can print it out and, of course, write right on it and practice it. That way you have practice other than using this textbook. And along with that, what you all will be tasked with on this next test, of course, will be burns, meaning you will classify burns based on the degree of burn. You will also go through the ways in which to treat burns, and not just treating the burns, but of course, well, we'll get more into burns here thereafter. but I'm just giving you all what is to come so you all can prepare well for the next test. I'll get back to where I left off now, of course, with the epithelial tissues. So epithelial tissue, as it is, it has functions, meaning it's found throughout the body. And I'll say that epithelial tissue is formed of tightly fitted cells forming a continuous sheet or layer of cells. So it covers the body, so it covers the body surface and organs. It forms that inner lining of body cavities and lines hollow organs. So I would say that if there is a lumen, and I don't mean a lumen such as a light, but I mean the lumen such as the mouth, the lumen class such as a blood vessel, the lumen class such as our, I guess I'll say our complete digestive tract, meaning from the mouth to anus. It's lined class by epithelial tissue. In addition, it is, of course, what forms our glands. So a gland is nothing more than one or more epithelial cells that secrete or produce a product, such as sweat, saliva, milk, wax, hormones, or even enzymes. And we'll get more to those in a moment. But there you are. So with epithelial tissues, they always have a free body surface, or that free apical surface that is exposed to, of course, if not the outside, the internal portion of the body, some open space. So with that, since it always is going to have that free or apical surface, it's also going to be, of course, anchored to some basement membrane. So just deep in the basement membrane, of course, would be that underlying connective tissue. So as a rule, and I hope you have your textbook class, I'm here on page 152. I'm here in class on page 152. As a rule, keep in mind that epithelial tissues lack blood vessels. So that does indeed mean that epithelial tissues are avascular. That means that if in fact you have ever had a paper cut, if you had a paper cut that did not bleed, the reason that that paper cut did not bleed is because, of course, it only went as deep as your epithelial tissue. So, of course, had it gone any deeper, of course, and penetrated class the basement membrane, and then gotten class into, of course, I would say that dermis, or gotten class into that connective tissue, you all would have then bled. You all would have then bled. So next up, I'll continue on. So with that being stated, class, just keep in mind that those nutrients that are needed, they diffuse to the epithelium from that underlying class connective tissue. And the connective tissue class, if you have not heard yet, it, of course, has an abundant or a lot of blood, meaning an amazing blood supply. It, class, is what allows us to do everything we do as far as taking in those nutrients. So continuing on with epithelial tissues, it states in your text they readily divide. And I'll say it a different way. I'll say that epithelial tissues, class, they are mitotic, meaning the epithelial cells, excuse me. But of course, those cells do make up those tissues. So I'll say again, the epithelial cells, class, they are mitotic. And when I say that they are mitotic, that means that they, of course, they divide. Meaning, for instance, one time may have been that you had some form of an injury. I don't know what the injury may have been. Maybe you had a scratch, maybe you had a cut, and maybe even was a mosquito bite. I know here myself, I was fixing a bottle for my daughter. She's 4 months old now, getting big too. And I was dipping the powder. She's drinking milk. That is, of course, made just by water and powder. Do a little shake, 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 shake. So I was dipping in to get that second scoop out and used my left hand because she was in my right hand and she was ready to eat, very ready to eat. And I just happened to, of course, graze my knuckle against the edge of that cylinder. And of course, you all know what happened next. It cut me, and of course it hurt, and I bled. Not a lot, but of course a little. So what I'm getting at is those epithelial cells, they rapidly divide to, of course, replace those damaged cells, to repair what, of course, has been, I guess I'll say, damaged. And with that, I'll just take this to parrot because you all should be making these connections all along. Keep in mind that unlike neurons, which are amitotic, these epithelial cells are highly mitotic. They divide and divide and divide. And I won't say they're dividing all of the time, but they most definitely do divide. So just keep in mind, of course, also those epithelial cells that line the stomach and intestines, those are continually damaged and replaced. And don't want you to think it's something that's necessarily bad, but it does happen. I say all the time because, of course, we eat, we drink, and of course, those foodstuffs do move class through that digestive tract. So, as I've mentioned already, class, those epithelial cells, they're tightly packed together with desmosomes, and they form that protective barrier. So they keep, of course, that is not the self, meaning that non-self, from, of course, entering into our bodies. We must have it. So in addition, class, to, I guess I'll say, forming that protective barrier, what they also do, class, is our epithelial cells are here for secretion, absorption, and even, class, excretion. So keep those things in mind, class, as we continue on here. So what I'll next get to, of course, is the classification, class, of epithelial cells. And this is done, class, in two ways. So epithelial cells can be classified, class, not only by class, shape, but also, class, by layer. So I guess I'll leave it here, class, and just go on through it. First things first, I'll classify them by shape. So squamous cells, class, are thin, flattened cells. I say again, squamous cells are thin and flattened. As I've said it that way, just keep in mind thin, flat cells, squamous cells. Next up, class, are cuboidal cells. So cuboidal cells are shaped like a cube. They are cube-like. So in stating that they are cube-like, it's just like a cube. And of course, you see that dark staining nucleus, class, within the center of the cell. Up next, class, would be, of course, those known as columnar cells. So columnar cells, of course, are taller than they are wide. And of course, the nucleus, class, is typically, class, going to be at that bottom portion of that cell. So now that I've classified the cells by shape, I'll now classify these epithelial cells by layer. So there's only two different ways to be classified, at least that we'll be using. So first things first will be simple. So simple means one layer, such as simple squamous. Or I guess I'll say simple squamous. I guess I'll also add simple cuboidal, but of course, or simple columnar. But that just means, class, that it's one layer of squamous cells, or one layer of cuboidal cells, or even, class, one layer of columnar cells. Next, the class is stratified. So the next layer is stratified. So stratified, class, means that it has many layers. So, of course, if it were to be stratified squamous, that means that there are many layers, class, of those stratified cells. And I would leave it as being stratified squamous. There's not a case in which, classes, you all will see stratified cuboidal, or even, class, stratified columnar cells. And then one class that is very different, is that it'll be called pseudo-stratified. So pseudo-stratified cells, I said that they are very different in that it's one layer of cells. However, class, it appears to be, of course, many layers of cells. So having done this, class, keep this in mind as we continue on. So we'll now, class, begin with simple squamous epithelium. So as it states, it's consisting, class, of a single layer of thinned, flattened cells that are tightly fitted together. And it states in your text, for, I guess I'll say, for help's sake, much like, class, tiles are on the floor, or even the hardwood surface, class, that is, of course, on the floor. And the nuclei, class, are typically going to be arranged in the center of those cells, be it, class, a side view or a top view, as you all can see to your, immediate right from figure, class, 5.3a. So that's the perfect example, class, of simple squamous cells. And 5.3b, class, is there. And if you look close to, class, at 5.3c, this shows a side view. So in this side view, class, you can see, of course, the dark staining nucleus there, and just deep to that, class, is the connective tissue, with, of course, other parts being, of course, lots of connective tissue. So to help you with this, I'll continue on and just state that we find these simple squamous cells, in areas, class, where I say cellular transport must occur. So the lungs, class, by way of our alveoli, are the perfect place to find these, meaning the air sacs. So it allows, class, diffusion to occur efficiently, class, and effectively, because, of course, this is simple squamous one thin layer of cells. And of course, that also means, class, there was just one, excuse me, one lipid bilayer for it to pass. So there's not a long way, class, for the gases to pass, meaning the, of course, carbon dioxide class to, of course, leave, and the oxygen class to, of course, diffuse in from a higher to lower concentration. So filtration, class, also occurs there. And with that, also keep in mind, class, that it's part of course, the lymphatic system for the lymph vessels. And then the very same way, just keep in mind, since this is thin and simple, damage, class, can very well occur here, class, quite easily. So up next, class, is simple cuboidal. So one layer, cuboidal shaped cells. This is, class, epithelium. So with this is what lines, class, the follicles, class, of the thyroid gland. It covers, class, the ovaries, and it lines most of the kidneys, tubules, and ducts in certain glands. So having gone in this direction, keep in mind that those cuboidal cells, class, typically make up ducts. And those ducts, class, are there. And what's typical of those cuboidal cells, as you all can see here in figure 5.4, I guess I'll go with 5.4b as in boy. What you can see here, class, is those dark staining nuclei are right there in the center. And it looks pretty uniform, class, in shape and structure. So this is, class, simple cuboidal epithelium. So with this, I'll go on and keep on stating that you see in the center, class, is the lumen. So that's that opening, class, meaning I said that they may even, class, make that duct for, of course, the secretion, class, of some product, or even, class, waste. And as it states that this, class, functions to A, form urine in those glands, and of course secrete, class, glandular products. This is, class, simple cuboidal epithelium. So up next, class, is of course simple columnar. So with simple columnar epithelium, it's here, class, yet and still a single layer of cells that are longer than they are wide, and the nuclei, class, typically staying there at the bottom in the center. So with this, it's at that base membrane that you find the nuclei. However, class, with this, many times simple columnar cells, or simple columnar epithelium, class, has cilia. So the reason in which the cilia is there, class, is to allow, class, mucus, I would say, to move. And you're saying mucus, yes, mucus, class. Mucus, class, by way of the respiratory tract. So in the event, class, you have ever known someone who was a smoker and has smoked, class, for a long time, you may have heard that person, class, have that cough. I say that cough because, of course, that cough that is there because the cilia, class, of those pseudostratified columnar cells is no longer, class, functioning until, of course, beat the mucus out of his or her lungs. Now I'll get back to simple columnar. So with the simple columnar, class, the cilia here are found, class, in the female reproductive tract. So here, by way of the uterine tube, class, it's moving that oocyte, class, in order, of course, for implantation, class, to eventually occur, after which, of course, being fertilization. So there's also, class, areas in which they're in the body that has simple columnar epithelium that is not, class, ciliated. So that is not ciliated, class, will be found in the uterus itself as well as in the digestive tract, even in the stomach and small intestines. So with that, I'll also mention here that in the event, class, that the simple columnar epithelium is there, it may very well be there, class, in the digestive tract with microvilli. And I mentioned microvilli here because microvilli, class, are here to function to increase the surface area. So there they are, the microvilli. They're very small here at the free surface. So this, class, is the lumen. So the microvilli will be there. So what happens with the microvilli, class, is that the microvilli increase the absorptive capacity, class, of the small intestine to allow for efficient, class, uptake of those nutrients from, of course, what you've eaten or what we've eaten. So having done it in that way, that's why, class, the surface area, class, of the small intestine is so large compared, class, to, I would say, other places in the body. Now, having done that, what I'll next get to is going to be the goblet cells you see. So those pink cells class shown here, are what are known as goblet cells. So those goblet cells secrete mucus, and the mucus is secreted class to protect. So they protect class as the foodstuff does indeed class move through the digestive tract. So from here, we'll continue moving on class. And yeah, give me just a moment here. I was thinking about something as I mentioned the small intestine. And it's important to know. Yes. So I mentioned that the small intestine has microvilli. And those microvilli are what we find class on the villus that increase the surface area of the small intestine. And I don't see here a number on the surface area listed, which I thought was listed. I'll now continue. So now class 2, pseudostratified columnar epithelium. So with pseudostratified columnar epithelium, I won't spend much time here, class. This is found in the respiratory tract, I mentioned earlier, class, with cilia, and of course, it's covered class with mucus. So the cilia class is, of course, what beats the mucus out of the lungs, and of course, it's trapping class, meaning because the mucus is sticky, it's trapping dust and microorganisms that enter by way of the air in order class to keep us alive, and of course, healthy. Up next class is stratified squamous epithelium. So with stratified squamous epithelium, what happens here is there are many layers, class, of those epithelial cells. So as you see it here, class, that is all stratified squamous epithelium. I would hope you say that looks starkly, class, different from what we just saw. So to help, excuse me, to help you with this, I would say a major reason that cells are stratified here in this way is for class protection. So with this, the farther those cells class get from that basement membrane, which looks pretty purple here from those dark stained nuclei, the farther those cells get, of course, they're less and less class apt to, of course, receiving nutrients from that basement membrane by way of the connective tissue and blood vessels that are contained there. So of course, the cells here, class, are actually dead, and they're protected. So depending, of course, upon where you are, such as in the skin, those cells class are also keratinized. So keratin class in this way class is a protein. So this keratin class is a soft form of keratin, unlike that hard keratin class that is found class in your nails. What it does, it of course produces that covering of dry, tough protective material that prevents water loss and of course prevents other substances class from entering into, of course, our body, such as those chemicals and microorganisms. So in cases, class, where that apical surface is not the free body surface, that will be a class a moist membrane. So you find class stratified squamous epithelium lining class the oral cavity, meaning, of course, when you will have the lab on cells and you look at buccal cells, that's BUCCAL, buccal cells, you were seeing class those, of course, stratified squamous cells that, of course, you just scraped off with a toothpick or just looked at class in the lab manual. The very same way, class, this is found in the anal canal as well as in the vagina. So keep in mind, class, in these moist areas, class, that these cells are still alive that are at that apical surface, and they are not keratinized cells in these areas. I repeat, they are not keratinized cells in the esophagus, vagina, the anal canal, or even, class, oral cavity. I will not, class, touch stratified cuboidal, even though it mentions, class, where to find it. It will not, class, be on the test at all. I will also, class, skip stratified columnar cells because, again, you will not, class, typically find this as being one of those typical types of tissues. As far as transitional epithelium, class, I'll do this quite quickly. With transitional epithelium, this is excuse me, found, class, in the urinary bladder, the ureters, class, and part of the urethra. That, class, is the only place in the body we find it. I'm not saying that it's not important. However, I will say that this class can respond to, of course, that increased tension from, of course, that filling bladder. In the meantime, class, that is enough about transitional epithelium. I'll now, class, move on to glandular epithelium, here on page 157. So with glandular epithelium, class, just keep in mind that those glands secrete their product. And class, keep this in mind. I said they secrete their product. Meaning, if it's a product class, it will be secreted. If it's a waste class, it will be excreted. So having done it in that way, they secrete the product class onto surfaces such as, of course, the skin, or even, class, the lining of the digestive tract, or even the lining, class, of the digestive tract. So to help you with that, class, exocrine glands are typically, class, ducts, meaning have ducts. That's ducts, such as sweat glands, secreting, of course, their product, or excreting their product, class, to the free body surface. Now, if in fact, class, a gland secretes a product, class, into a tissue fluid, I repeat, if in fact, class, a gland secretes their product into a tissue fluid or blood, then of course that is the definition, class, of an endocrine gland. So as I said it that way, class, endocrine glands, they lack duct. They're ductless glands. So typical of which they secrete hormones, class, into our interstitial fluid or even, class, the blood. And of course with that, let's continue on. So we'll begin now with the exocrine gland. So that exocrine gland, class, it might be one epithelial cell, meaning being a unicellular gland, such as that goblet cell that secretes mucus. And it may, class, be composed of many cells, or be multicellular, such as, of course, our sweat glands, or even our salivary glands. So I won't spend a lot of time, class, on simple glands versus tubular glands. However, I'll spend a bit more time, class, when we get to specific types of glands. So here we are, class, with the glands that release fluid produced by exocytosis, meaning the American gland. So our American glands secrete fluid, class, products by exocytosis. This goes, yes, back to cellular transport. So examples of these, class, will be found in the pancreas, our sweat glands, and salivary glands. So next to which, American glands are also called eccrine glands, or our eccrine sweat glands, which you, of course, will find in the next chapter. Up next, so other glands, known as apocrine glands, class, what they do is they secrete or lose a small portion of their gland during secretion. So with this, class, that's happening with your ceruminous glands, which I've put on the test many times, which of course secrete cerumen, known as earwax, and even, class, in the mammary glands, which of course secrete milk. Up next, class, glands that secrete the entire cell are called holocrine glands. And those holocrine glands, of course, release the entire cell with product. And the example here, class, would be, of course, those sebaceous glands. And we'll do more with glands, class, in the next chapter. A lot more with glands. So from here, class, we finished up, class, with epithelial tissues. And one thing that I mentioned maybe a little quickly, class, is that with epithelial tissue, it also, class, I repeat, with epithelial tissue, it also serves as being, class, a receptor for our senses, such as that of smell, taste, hearing, and vision. So I'll stop here, class, because your textbook has it. However, the presentation does not. It mentions, class, that most exocrine secretory cells are merocrine, and then they're classified based on, of course, the secretion of either serous fluid or mucus. So we'll get more into serous fluid a bit later, but you also learned about serous fluid, class, back in our first chapter, when I got toward the end of the chapter, by way of the body cavities, meaning that serous fluid, class, allows, meaning lubrication to occur, to ensure, class, that the visceral and parietal membranes of those cavities do not stick. And the thicker fluid, class, called mucus, is rich in a glycoprotein called mucin. And of course, those cells of the digestive tract, the respiratory tract, as well as the reproductive systems, class, secrete abundant mucus, which is protective. So keep those things in mind. I am now ready for the connective tissues. So with the connective tissues, class, these comprise much of the body and the most abundant type of tissue, class, by weight. Thanks a lot, collagen. So having stated that, class, think of connective tissues as being therefore support of those other body structures. I say, class, that our connective tissue is associated, class, with every part of the body in some way, shape, or form. So with that, I'll give you a way, class, to contrast connective tissues with the epithelial tissues. So the connective tissues, class, I'll say think of it as having relatively few cells. I'll repeat, relatively few cells. And as I'll say it again, it's in almost, class, every organ in the body is there, class, supported by connective tissue. So it consists of cells, class, within a thread-like matrix. So with that, the cells here in the connective tissues, class, they are farther apart, and they have an abundant, class, extracellular matrix. And that matrix is composed of, class, protein fibers and a ground substance. So the ground substance is, of course, what consists of the protein and other molecules, class, and fluid. So just keep in mind that this is what binds and supports and provides that medium through which, class, substances can be transported, class. So having said this, let's get to those major cell types of connective tissue. And with that, you also see before you, class, the functions of this. I didn't mention functions quite yet, but I guess I should throw a few functions out there. So connective tissues, class, function to provide support and protection, as I mentioned earlier. They bind those structures together, such as with, of course, our tendons or even the ligaments. But they fill spaces, they store fat, produce our blood cells, and generally, class, protect against infections. I'll leave it at that and keep on moving. So now, to the major cell types. The first of three types, class, would be the fibroblast. So fibroblasts, they're the most common type of cell in the connective tissues. So what they do is produce fibers, class, by secreting proteins into the extracellular matrix. Done with those. Next up, class, are the macrophages. I repeat, the macrophages. So they originate, class, macrophages do. They begin, class, as white blood cells. And they're almost as numerous, class, as fibroblasts in some connective tissues. But what makes it important, class, is those macrophages are specialized to carry out phagocytosis. So as the body, class, interacts and has come in contact with things that are not part of the cell, what those macrophages do, class, is they engulf, class. I repeat, they engulf, they phagocytize, class, things that are, of course, not of the cell. So, as it states in your text, they're important, class, in defense against infection. So they play a role, class, in immunity, the macrophages do. Up now will be the mast cell. That's M-A-S-T, mast cell. So mast cells, class, will be found, typical of which to be near blood vessels, mast cells. So what they do, class, is they release heparin. I don't know if you all have heard of heparin before, but heparin, class, is what prevents blood clots, a blood thinner. So what happens, class, is the release of histamine stimulates inflammation. So I'm getting into that inflammatory response, class. So what happens is, by the inflammation that, of course, has been stimulated, is it dilates, class, those small arterioles that feed the capillaries, meaning those tiniest of blood vessels. And the increased blood flow, class, with that resultant swelling and redness, is, of course, the hallmark, class, of inflammation. Hello, that's the inflammatory response. And it may, of course, feel warm to the touch. So this, class, is inhospitable to those infectious viruses and bacteria. And it also, class, dilutes the toxins that, of course, may have been, of course, in us and in you, or in me and in you. So in the event, class, that you, I guess, would say sometimes like me, meaning if you have ever, class, had an inappropriate histamine release as part of an allergic response, this, class, can be quite uncomfortable, meaning that it's sometimes, class, prescribed to be, of course, the allergy medication called an antihistamine. And this, class, of course, is just, of course, to counter that misplaced inflammation and to reverse, class, the effects of course, what has been released. Thanks a lot, histamine. But of course, I say histamine is one of the better things, class, here on earth for you and for me. So next up are connective tissue fibers. And of these fibers, class, really quickly. So I said, class, thanks a lot, collagen earlier, one of the, of course, more important ones. So it's the most abundant fiber, class. And it's mostly, of course, meaning it's 25% of the protein mass in, of course, mammals, and it's just that the collagen protein. It's our main structural protein, so it's quite strong, found in ligaments and in tendons. Up next class is elastic, and of course, it's made of that spring-like protein class called elastin. Then thereafter class, well, I'll say elastic fibers are responsible for the vocal cords and their stretching, hence, of course, you hear my voice now. And then lastly, I'll get down to the reticular fibers. So with reticular fibers, these are the thin collagen fibers that are highly branched. So up next class, I won't spend nearly as much time class with connective tissue proper, but I'll get there now. So here we have clinical application class 5.2. And since I am here, class, at some point, take time to go over on your own cancer from clinical application class 5.1. We've done a little about cancer not last chapter, but from chapter 3. So here's a little bit more on cancer on page 162. Make sure you review class liver fibrosis. I repeat, please review liver fibrosis and heart failure. This is on page 162. So next up, class, is clinical application 5.2. I'll be quick, class, with this application. Keep in mind, class, that collagen disorders can very well affect you and affect me. In one case, class, it's called Marfan syndrome. Marfan syndrome. With Marfan syndrome, class, this can weaken the aorta, cause long limbs, a sunken chest, and even, class, lens dislocation and even spindly fingers. Next up is hereditary class osteoarthritis. With this class, the joints can be painful. And then chondroplasia class is when those collagen chains are asymmetric and too wide, causing stunted growth and deformed joints. Collagen class, it makes up over half of the protein class in bone, cartilage, and a large percentage class of our dry weight in our skin, tendons, and ligaments. It's a major important class to you and me. So take a bit of time, class, to review clinical application 5.2 on the abnormalities of cartilage. So now, class, to connective tissue proper. I won't just deal with why it's called that, and I really won't deal with class areolar connective tissue. What I say about it, class, is it fills the spaces, class, between muscles. That's what areolar connective tissue does. And you see, class, areolar connective tissue here for you, and it's shown, class, in figure 519A. This, class, is a perfect figure showing areolar connective tissue. What you all can see a lot of their, class, is a lot of those collagen fibers which look stained pinkly, or pink, not pinkly. And of course, you see the elastic fibers which stain pretty dark, class, like those black. And then the fibroblasts, which are those circles that are, of course, the cells. Next up, class, is adipose. I'll spend time, class, with adipose. So you can call this fat tissue if you'd like, adipose or fat tissue. It all looks the very same microscopically, class, such as you all see on page 165 in figure 520B. 520B. So, of course, with adipose, the cells, class, of adipose are known as adipocytes. And with that, they store fat in droplets, pretty much. So what you're seeing there, class, in the figure is nothing more, class, than that fat droplet. And of course, the cell membrane is what surrounds. And then just outside is right there, the nucleus. So here, class, this is what provides a bit of cushion, the adipose does. And along with, providing cushion, I would say adipose is right there with blood vessels. And of course, the blood vessels shown there in cross section. But with this, class, it stores energy. The fat is a source of energy. So it insulates, class, the body. So A, it insulates. B, it stores energy, class. And with that, in the event that it's needed, class, it can be used to, of course, synthesize ATP. So we have mostly white fat, we being the ages we are. However, class, in newborn children, class, I said in newborn children, class, they have much brown fat. And of course, it is what keeps them warm because newborn children, class, are unable to shiver. I'll move it on now, class, from connective tissue proper to specialized connective tissue. And I'll begin here, class, with cartilage. So I'll begin with the cells that begin with adipose. So of course, adipose had adipocytes, where in cartilage class, the cartilage cells are known, class, as chondrocytes. That's CH, where you see it there, chondrocytes. So chondrocytes, class, they lie in lacunae. I say again, chondrocytes lie in lacunae. So with this class, chondrocytes, of course, are the cells, class, of cartilage. Well, cartilage, class, as a whole is avascular. It has no blood supply. It has no blood supply at all, and it is also, class, not innervated. So when you think of cartilage, class, think of it as having cells known as chondrocytes. B, it's avascular. C, class, it is not innervated. So that's the very reason, class, that cartilage is so slow to heal. If in the event that you've torn cartilage, class, that's why the cartilage that you torn took so long to finally heal, if indeed it did heal. And with that, it's much of the matrix that's seen around, class, the chondrocytes, which of course they're lying in those lacunae. And we'll deal with, well, there are three types. We'll begin with the first of three, and not so much the second two. So the first of three, class, is called hyaline cartilage. It's the most common type of cartilage, and it's found, class, at the tips of long bones where they articulate, class. And we also find a class in the respiratory passage, meaning we have I think it's 15, I'm guessing. I think it's approximately 12 to 15 C-shaped hyaline cartilage. And their class, ensuring that the respiratory tract, of course, does not collapse upon, of course, breathing. And next of which I'll show you all this here now. So you look closely, class, that's that matrix, that extracellular matrix. This class would be, of course, the lacuna, and within the lacuna, class, is the chondrocyte. So this is the lacuna chondrocyte with nucleus. There it is, hyaline cartilage. From here, class, moving right along to bone. It's also called osseous tissue. I always call it bone. So let's get to bone. So I'll do bone, class, the same way I did class adipose, meaning adipose had cells known as adipocytes. Whereas I did also the same thing, class, with cartilage. Cartilage, class, has cells called chondrocytes. Well, now that we're here in bone, class, bone has cells, class, called osteocytes. So with that being the case, bone, class, like cartilage, has cells known as osteocytes, which lie in lacunae. So having said that, bone is hard. And the reason that it is hard, or one of the many reasons, is because, of course, it's salts, meaning those calcium phosphates, class, and the calcium carbonate. That, class, is why bone is, I would say, as strong as steel, class, to resisting those twisting forces because of those pillars that are within. I won't have enough time, class, to get to those pillars necessarily, but if you want to learn more about bone, please do meet me, class, for those open lectures, class, Monday through Thursday from approximately 8 a.m. to 10:30 a.m. So moving on, class, with bone. What makes bone, class, I say, unique, and I say even different, class, from what we learned about, class, with cartilage, is that bone, class, is highly vascular. It has an amazing blood supply. It is also, class, innervated. So yes, it has a nerve supply. I'm glad to see this here, but I'd rather, class, get to the microscopic picture here. So I say again, it's highly vascular. So this is going to be on page 169, class, and it's called figure 528b. So this, class, is that osteon system, or that Haversian system. That's Haversian, Haversian system. So that's called the osteon canal, the black portion at the very center. That is the, I say again, the osteon canal. I don't know what this is doing here. There it is. Or Haversian canal. And it's within, class, that black circle, that osteon canal, where you find, class, the blood vessels, meaning the artery, the vein, as well as, class, the nerve. Meaning this is why if ever, class, a bone has been broken, it hurt. So to continue on, class, you have a lab coming up, so make sure you take your time. But of course, we have those concentric rings. And it's those concentric rings, class, that contain right there. That would be, class, a lacuna with an osteocyte, That is also a lacuna with an osteocyte, and that too is a lacuna with an osteocyte, and that is also their class a lacuna with an osteocyte. So it's those concentric layers that make bone strong. And then what allows class those osteocytes to communicate are called canaliculi. So it's those canaliculi that allow class those osteocytes to gain information class about your bones and my bones. To put another way, class, meaning your bone remodels itself all the time. If you were to class, I guess I'll say be someone who does, I guess I'll say not much each day, your bone, of course, will respond to that by, of course, becoming weaker and weaker and weaker from those osteoclasts. They reabsorb bone. In the event that you were to get up one day and start running each day, or you were to get up one day, class, and start lifting weights each day, then, of course, your bone will still, of course, respond to such by way of those canaliculi, allowing class those osteocytes to communicate. And then, of course, your osteoblasts, which, of course, would then lay down class more and more bone matrix, and that would class strengthen your bone. We could do more with bone, but I won't do so much with bone now. Class, take time and study. There are more things to go. And just keep in mind, class, that within your bone, we have a marrow cavity. So we have your red marrow cavity, class, which of course is found within that spongy bone, not the compact bone. And it is within that red bone marrow, class, that hematopoiesis occurs, meaning the way in which, class, we make all blood cells. I'll say again, we have adult stem cells within, of course, our bone by way of the spongy bone, the red bone marrow, class. And that's, class, where hematopoiesis occurs, meaning the synthesis, class, of our bone, the synthesis of, class, our blood cells within our bone. A tongue twister, eh? Up next, class, is going to be what I call blood. Yes, blood, class, is a type of connective tissue. So having said it that way, keep in mind that, yes, this called blood, class, has a fluid matrix known as that plasma. And as blood is, to not get ahead of myself, I guess I'll state it as being the types of cells. So there are red blood cells, which I think you all can see. And this is shown to you all, class, in figure 5.29. I'll say again, this is shown to you all, class, in figure 5.29b. Red blood cell, red blood cell, red blood cell, and that, class, is a white blood cell. And no, class, white blood cells do not stain white. They look purple. So we have red blood cells, white blood cells, class, and platelets, which there's a very, very small platelet. I would have chosen a larger platelet than that, but yes, that's a platelet right there, how small it is. And this, class, is the matrix, meaning the plasma, that liquid matrix, class, found in blood. So as blood is, how do I want to do this stuff? I guess I'll say that it's specialized within an intercellular substance, blood by definition. And let me see if I leave anything out. Nah. You all learn more about blood, class, and anatomy too. This is just an introduction to the types of tissues. But just keep in mind, class, that the red blood cells are the only type of blood cells that function entirely in blood vessels. Because of course our white blood cells, class, they migrate, class, from the blood through the capillary walls to the connective tissues, where they carry out, class, of course, the activities until they die, keeping us alive. All right. So now I'll move on, class, to types of membranes. So first, the type of membrane, class, with the serous membrane. We did this back in the prior chapter. These, of course, what line, class, the body cavities by way of maybe that parietal peritoneum, the visceral peritoneum. And of course, what between the two will be, of course, that serous fluid, that watery serous fluid that allows, class, the lubrication to occur. Excuse me. Up next, class, will be the mucous membrane. So the mucous membrane is that cutaneous membrane, or called the skin, and part of that integumentary system. We'll do more of this in the next chapter. But of course, this is what lines the digestive, the respiratory, the urinary, and reproductive tracts. And the goblet cells, of course, what secrete the mucus here. And then finally, class, the cutaneous and synovial membranes. I won't do much at all, class, with the cutaneous and synovial membranes. As the course is, there's not a lot of time, class, for joints. And then, of course, I mentioned again the cutaneous membrane, called the skin, and the mucous membrane, class, which of course is by way of those tracts, the digestive, the respiratory, the urinary, and reproductive. So from here, I'm moving on, class, to muscle. So please, class, keep in mind that this is only an overview class of these final two types of tissues. In other words, class, we have an entire chapter or two on muscle. It's called chapter 9. So this is an overview. So muscle class, muscle tissue, is a specialized class to contract. I mean, that is the reason why. So they can shorten class and they can thicken. So the muscle cells class, typical which to be called muscle fibers. And with this, there are approximately class 40% of the body by weight is skeletal muscle. And then the other 10% class is smooth muscle and cardiac muscle combined. So muscle class carries weight, if I can say it that way. So I'll now, class, get a bit more into muscle. So typical of which is to have those long cylindrical shaped cells, and each muscle fiber class contains many thin parallel contractile units known as myofibrils. So there are two proteins involved, and they're known as actin and myosin, and they play that key role, class, in contraction. I mean, without those, class, contraction would not occur. Let's get to it. It's called skeletal muscle tissue. So skeletal muscle, class, is attached to bone. It's voluntary. That means you control it. I control it. We are here controlling it. Hence, of course, it's known as being, class, voluntary muscle. It is striated, class, as you all see there, and that's figure, class, 530B, here in figure 530B. So that is it. So that's those little alternating light and dark bands, which I'll mention a lot more about in chapter 9. Those are the striations. This class is one muscle fiber. That class is another muscle fiber. And what's unique, class, about these muscle fibers is that here in skeletal muscle, class, it's multinucleate. So the purple I've left the inset on shows, class, that it has many nuclei, class, per muscle fiber, as opposed to, of course, what you all learned for that typical cell, meaning you were taught someday, class, that the typical cell has only one nucleus. Well, I don't call these cells anymore, class. These are known as fibers, and of course, it's a multinucleate class structure. So, of course, muscle will not contract, class, unless first. I repeat, a muscle will not contract unless first, class, it is stimulated, class, by a nerve cell. And since I'm referring to, class, skeletal muscle, you could say that a motor nerve cell. That is the only way, class, contraction ever occurs. It has to be, class, electric. Then, of course, that muscle contracts. Up next, class, is smooth muscle. So to contrast, class, smooth muscle is not voluntary. We cannot control it. To contrast again, class, smooth muscle has no striations. It is not attached to bone. It, class, is what lines those hollow organs. So it is what, class, makes up that blood vessel. It is what, of course, is around that stomach, class, the small intestine, class, the large intestine, class. It is smooth muscle that I guess I'll put as being is uninucleate, having one nucleus per cell with those spindle-shaped muscle fibers. And it's, I guess I'll just put it out there, class, it is smooth muscle that kills, class, a number of people each and every year. You say why or how? Well, it's in the wall of the digestive tract I mentioned. It moves foodstuffs, class, through the digestive tract by way of peristalsis. So by way of peristalsis of the gut, those alternating, class, contractions and relaxations, class, foodstuffs moves through the gut. I'll also mention, class, by way of the uterus, class, having those contractions there that occur by way of oxytocin, class, being released. And of course, is that being positive feedback or negative feedback? By way of those alternating, class, contractions and relaxations when the child's head reaches the birth canal. I hope you answered that question correctly. And of course, in our blood vessels, class, it changes what is that set point, and of course, you get that slightly contracted state. And that, class, of course, is what causes hypertension. And it's that, class, that kills a number of people every day. So please, class, watch your salt intake, because of course, I'll just put it out there now, class. Water always follows salt. So of course, the more salt, class, that you intake, the more water, class, you retain, and of course, the higher, class, your blood pressure may very well be. So that would exacerbate, class, the issue. And then, of course, the doctor may prescribe, class, some, of course, drug. Up next, class, is going to be, and I can't stress enough, class, it is smooth muscle that causes the vasodilation. It causes, class, the vasoconstriction. So I cannot stress enough, please watch what we're eating. And I say you, I say we. And up next is going to be cardiac muscle. So cardiac muscle class is only found in the walls of the heart. And as a stated class, cardiac muscle, like skeletal muscle, is striated. It still only class has one, or repeat, it still class only has one nucleus per cell. But here class, we have those branched complex networks. So it's branching that is here. And what helps you to identify class, whether it's skeletal muscle or cardiac muscle, is well, A, it's branched. And if you look at class figure 5.32b, you'll also notice those dark lines that are there. Those are known as class intercalated discs. So those dark lines you see are known as intercalated discs. And that class, I say, is your hallmark. That is what to look for to determine class, whether it's A, skeletal muscle class, or B, cardiac muscle. And with this, what I also say about cardiac muscle class is that it has those intercalated discs class at gap junctions. So that's where those, of course, fibers join, the muscle fibers join. So keep in mind, class, like smooth muscle, cardiac muscle class is also involuntary. And it has its own pacemaker cells. They're called class the sinoatrial node and the atrioventricular node. Well, you all will do more and more with that in anatomy too. I told you this class is just an introduction. But I'll keep in mind, class, that the heart class can continue to function even without nervous stimulation. That makes the class so amazing. So this class that the heart is, it's a pump. It's a pump. It pumps the blood class throughout the body. Pumping class of blood throughout the chambers and, of course, then into the blood vessels. And, of course, throughout the body. Gotta love that heart. So the next class is nerve tissue or nervous tissue. So with this class, with nervous tissues, they're found class in the brain and spinal cord and the peripheral nerves. I repeat, nervous tissue. Nervous tissues class are found in the brain, spinal cord, and the peripheral nerves. So now that we've made it this far, I'll say that nerve tissue class controls our muscles and glands. If I were you, I'll write that down because that's what it does. It controls our muscles and glands, meaning the effectors class of it. So with this class, it has two types of cells. They're known class as neurons, or nerve cells, and of course other types of cells are known as neuroglia or glial cells. Those are the support cells class of the nervous system or nerve tissues. So what the neuron does, class, is that's class that type of cell that receives and transmits signals. I repeat, the neuron class receives and transmits signals. So these specialized cells class that are here are comprised class of a number of parts. If I were want to draw, which I am, I'd love to draw more, but I'll use this figure class shown at the bottom. That's figure class 5.33a. So this class is a multipolar neuron you're seeing here. A multipolar neuron. So what these class are here are known as dendrites. So dendrites class are that receptive region class. I repeat, the dendrites class are that receptive region, meaning they receive the signals, and they then class transmit those signals they receive to the cell body. The cell body is this little circular portion here, and it contains the nucleus there as you see it, and it also contains class the Nissl bodies. That's Nissl, Nissl bodies, or the chromatophilic substance, however you want to call those. I learned them as Nissl bodies a long time ago. And with that class, the neuron will then continue class to move that information down the axon hillock and then down the axon. And the axon class is what will transmit that information class. It transmits the nerve impulse away from the cell body. And then, of course, it eventually class will get to the synaptic knob, and it will either class go from this pre-synaptic neuron to a post-synaptic neuron, or from this neuron here class to a muscle fiber. I told you, that's what happens. These neurons class, they control our muscles and our glands. And up next class, just keep in mind that they can coordinate, they regulate, and integrate many bodily functions class. These neurons do. So the support cells class, known as neuroglia, they support and nourish neurons. And with this, they're here class to ensure that the neurons have the necessary growth factors and nutrients that they need. So having gotten this far in the chapter class, that has been, of course, chapter 5. Please study well. Please take time to review this information class. And just know that there very well may be a couple of short answer questions class about these tissues. And even photographs. I like photos. I like pictures. Meaning I like IDs. So you see the picture class microscopically, as you all will do the lab that I've assigned for this chapter class on tissues. And what you'll do, class, is I hope you have your description, your function, and location ready. I say again, DFL, your description, your function, and your location ready upon class seeing that tissue type. Thank you all for listening, class. This has been your instructor, Scholar Huff.